Okay, let's continue cheating. Why is this cheating? Because reading the book and watching these videos and studying doesn't involve going out and watching, and we can learn what people saw year after year. You got to watch this year after year around the globe, separate tribes, separate courts, separate whatever, until they could start communicating and then sharing and then growing. So we're learning all this without doing it, but I encourage you to get outside, and I'll encourage you again. What are we doing? We're looking up and wondering and going, wow, what's going on with that? We don't have cell phones, right? We don't have any of that stuff, and I'm going to get rid of this now to give myself room for a nice big picture that'll tell you a lot about our seasons and how humans figured this thing out, right? So this is, as I say, a human endeavor. It's a human wondering, and it's a human evolution of awareness, knowing our place in space, but also being able to know when to plant and to try to start figuring out things that are true, that we can depend on. Along the way, we made up lots of stories, and the stories you might want to believe them, and maybe it's the best you got, but at least know that, well, I think this is true, but I don't know. So 5 astronomical objects that we're looking at with our naked eye, what people could see around the globe, and what they notice. You could see stars as dots of light that are fixed, and by fixed, I don't mean they just stay right there all the time, except one, Polaris, the North Star. They move, okay? But they move together. So they're fixed relative to each other, right? Wherever my right shoulder goes, my left shoulder is fixed, hopefully. Hopefully they're fixed. So that's what we mean by that. And then there would be streaks, and people wondered and they were afraid, and they'd say bad luck and whatever. We'll check out those later in chapter 9. We'll get into this in chapter 10 and 11 more. Planets, we're going to get into that a lot, chapter 7, 8, and 9. But those dots didn't stay fixed. It'd be like this shoulder moved over there, and this one stayed there. So again, we talked about those, and people wondered if there were God's days of the week and so on. And now we're doing sun. It's the only one that looks like that. We didn't know back in the day, cheating, that sun is actually a star. And these are just really far away. Didn't know that. So common and understandable, and not making fun of anyone, to think of it as a god. Helios, Greek, Ra, Egyptian, Inti, Incan, Sol, it was the Latin term for it. Sonan, you'll see Sunan, and Sonan, and Sun. The sun, because it was the only one, but then you go, wait a minute, these are names for that thing. Just like we don't say the Jupiter, we say Jupiter or Mars, not the Mars. But this reflects that fact. I've talked about that. Let's go over that. We're going to finish this off. Now, also we're going to do moon, and we're just going to watch moon. Now this is going to tie into a year and calendar, the calendar that people created, and seasons. This really ties well into seasons. Moon phases were also used to track time, and a lot of peoples around the globe early on used moon phases. They counted the moon phases, new moon cycles, and those were roughly months, very close to months. And again, it was the god, lots of names for moon. And so we're going to talk about the moon, but now we know that there are other moons and phases. And also, with your naked eye, there are these 3 fuzzy patches, and I'll just underscore this real quick, that, remember, they didn't know what they were. What were they? The little fuzzy clouds. They weren't star dots. They were fuzz balls, but they always stayed there. So if I have a star dot here and a fuzz ball here, it always stays there. That's weird, because clouds come and go, and they move. So what was that little fuzzy? And you could tell with your eyes, it looked kind of fuzzy. Like, what is that? It wasn't known until about 100 years ago. Think of Hubble, and Einstein was involved in this too, but lots of folks. And Henrietta Leavitt, she had a discovery that was huge. It allowed us to know about galaxies. Northern hemisphere, 1, southern hemisphere, you can see these 2. Didn't know what they were. we're going to get rid of all this. But really quickly, I will say, if I haven't shown you, I think I might have, the Hubble. This is some old school. This is 1969. Now you just go on the internet and go spiral galaxy. Boom. You'll see, and you go to images. You'll see it. Barred spiral, elliptical, irregular. I mean, it's so cool, right? So, I don't know. Can you see this? Probably. It's a bunch of different galaxies out there now, and that was even then. Now we see them even better in James Webb Space Telescope. Different shapes, and you just go, I don't know. First you discover, then you see if you can figure out the whys and hows and such, right? So this is a little review of chapter 0. So as you move forward, always take time to review. Andromeda, our closest big neighbor, maybe with about 3 times more stars than us, something like that, right? Coming towards us. Andromeda, can you see it? That's a spiral. Here's another one. There's lots of them. Okay, I like these pictures. And wait a minute, what are those? That's not a fuzz. That's not a cloud. Those are stars. And we are, in our galaxy, which is Barred Spiral, halfway out. We're one little dot, one star. What if, how many billion? Small ones, 1 billion, 1/10 of a billion. Large ones, 100 billion, a few hundred billion, 1,000 billion, which is a trillion. And we're just one star with the stuff going around it. So we've got a context, but we don't know that. Put that away. Cheating. Once again, we are looking outside. And what we're going to watch today and tie into and give ourselves some power so we know when to plant our tomatoes, and that is we are going to watch sun. Okay? Helios Ra Inti Sol Sona. And which way are we going to look? Well, this is going to be important. We're going to look south to watch sun. And remember that memory aid. So we're going to build on what we've done. We just again review. We're going to review the idea about brightness and, dimmer and brighter and distance and all that stuff. Keep that stuff fresh as you review this. But for now, we're going to do sun. And again, we don't know much, right? Cheating, we know that if you shrank all of Earth now to a grain of sand, sun would be that big. You can get 100 Earths, 109 Earths across the width each way. So that's cheating a little bit. Now we're going to track sun. Okay, so we're going to track sun. And I'm going to do this. Make sure that you can see me. Okay. We're going to draw it like that. I'm going to talk about this a little bit. And then I'm going to get rid of this. Okay? So, can you see me? I think you can. Yeah. So we're going to watch sun. We're going to track sun. We're going to keep track of it. And people back in the day did some impressive stuff. They lined things up. So you got sticks, and you can line things up, and you can measure angles. You could create this and kind of make wedges and make uniform wedges, as many or as little as you want, but you could start talking about it. We're going to talk about how high sun is and where around our horizon it is. We're going to map it. Where is it? Where does it rise? Where does it set? How high does it go during the day? We'll go back over to that in just a second. Okay, so naked eyes, we're wondering. We don't know. We don't know anything about the size of sun. We don't know if sun is a star, anything of that nature. And so we're going to come over and notice a few things. So here's our list for sun that we want to know now. We'll talk about the layers of sun and stars and stuff in chapter 11. So here you have what we're going to do with sun. All right. We're going to observe sun. Okay. You've got to look from the same place, because if you look at it from a different place, it'll look like it's setting next to something different or rising next to something different. And even if you travel, 10 miles, so you can get a different perspective on it depending on where you are and so on. So you've got to find a place, make it cool. You're going to hang out there anyway, and good sound system and all that stuff, right? Lots of names. Ra, Inti, Helios, Sol, Sonos, Observe Sun. And we wonder, you've got to look from the same place. You're going to see tiny daily changes. So, every day you can. If it's cloudy, fine, well, you can fill in the gaps. But you see big monthly changes. So we don't really notice it day to day. You're gonna have to draw a picture and then go back out. In a week, maybe you'll pick up a change, but in a month, you'll certainly pick up big changes. And the other thing is that it repeats on a yearly cycle. And when people realize this, they clued into, hey, I can keep track of this calendar. They tied in seasons and so on. We're gonna watch and track this. We're going to sketch 4 things. We're going to sketch where sun rises, how high it gets around. Sun rises roughly east, but not exactly. And so exactly where will change a bit each day and quite a bit each month. It's funny, we don't notice this, right? Well, we're busy. It actually makes sense. It's fine. But we can notice it, and it's cool too. It's not that hard. So why don't we tie into this and share this with each other? How high it goes at noon, roughly noon over south, just to get a sense, right? How high does it go? We can measure that. It's called the altitude. That's chapter 2. How high does it go? How high is anything above our horizon is the altitude. But how high it goes changes a bit daily and a lot monthly. And where it sets, roughly west, rising roughly east, heading over south, and setting roughly west. But exactly where is why we got to pick a place to sit and watch it. And it'll change a bit daily and a lot monthly. This is what our ancestors did to keep track. They also watched stars, like what stars are out at night. That helped them a lot. And then they watched moon cycles. And they started to chunk out time because they didn't know it. They didn't have the answer. They didn't have YouTube. Additionally, then, this is, of course, tricky. You can't see what stars are behind the sun because you can't see any stars. And behind implies that stars are farther away. We know they're light years away and the sun is 1 AU away. Why we know that now, but back in the day, it was like sun was in those stars, whatever. So what sun is in front of really changes a bit daily and a lot monthly. All this. Daily changes that go unnoticed, monthly changes that you absolutely will notice if you just pause a little bit, pick one spot, and watch any of these. How do I know what's behind sun? Well, look at what rises before sun rises. When you can see those stars, draw pictures. You got to draw a bunch of pictures and check it out. That's how people start figuring this out. And then after sun sets, what sets after sun? And you keep figuring it out, and you'll piece together a whole picture. And what you find is that sun appears to travel along a circle through the stars. I know you can read, repeating the circle yearly. Every year, it repeats. And you go, hey, that's kind of wild. I bet we should track that. Maybe there's something crazy and mystical about it. Who knows what? And people around the globe notice this without talking to each other. You don't have to talk to each other to notice that. Sun travels along a circle. You can call it a line through the stars. It repeats. It's called the ecliptic, chapter 2. And it goes through a strip of stars that the Greeks called the zodiac, but you can call them other things than other people did. So this zodiac is not real, that's the made up part, but it is, they do go through that strip and you can cut it up however you want. So that's what sun does, and we're going to watch that and be able to describe that. How? Again, with pictures. So let's be able to draw pictures. And I think I'll keep this one kind of short as a setup. So here's the pictures. Then I'm going to do a slideshow. And then we're going to draw this picture. And what I want to point out to you here, this is an important idea because sun does not rise directly in the east except on 2 days. It does not set directly in the west except on 2 days. On one day, it rises the farthest on the north side of east. And then you'll find that it rises, looking just at sunrise, rises directly east, rises the farthest south side of east, rises, remember it goes back and forth, then directly east, second time in a year, and goes back, a yearly cycle. Now that's true over here too. If it rises the farthest, the north side of east, it'll still go over south, but it's going to set the farthest, the north side of west. Remember, it's still going to be here. And keep in mind, let me remind you, that we are looking south. And so let's draw some hair. This is not your face, this is your hair, right? You're looking south. So you got eat sandwich. Oh yeah, eat sandwich, we remember that. So on one day, it rises here, goes up real high, and goes here, and then it again gradually goes back. Directly west, farthest south side of west. Directly west, farthest north side. Back and forth on the sun setting, back and forth on the sun rising, and we'll see the height also changes. We'll draw that next time. I'll start you out with some pictures.